Can we build entire moon bases using nothing but lunar soil? Well, there is one company working on that idea. SpaceFactory was founded in 2017 by a team of architects and engineers with a dream to make human habitation possible throughout the solar system. They're now headquartered in Huntsville, Alabama, Rocket City, USA. In 2018 and 2019, they entered the NASA Centennial Challenge to develop and design technologies for Mars. Their design, called MARSHA, won overall first prize and netted them $500,000 in prize money. Not bad, considering over 60 teams competed across all phases, with only a few making it to the finals. With this prize money and with a small business research grant from NASA in 2024, they've been developing the technologies to build infrastructure on the Moon and Mars. It turns out you can do construction using lunar soil and rocks, sprinkling in some special ingredients and some cool technology. SpaceFactory is testing and verifying their technology at NASA's Kennedy Space Center's Swampworks Space Lab. This facility gives them access to a vacuum chamber for testing in the extreme temperatures during the lunar night and plenty of fake lunar soil that mimics the real thing to test construction technologies. Their use of large-scale 3D printing for the Moon and Mars reminds me of ICON, which has similar goals. In fact, they 3D printed the Mars Dune Alpha habitat prototype for NASA using simulated Martian soil. Hey everyone, quick thing before we dive in. If you leave a comment on this video with your thoughts or opinions, it could get highlighted and read out loud in my weekly live stream this weekend. Here's what happens. I recap every video I published this week with all the slides, images and extra clips you might have missed. Then I pull up the comment sections, read some of the best ones, maybe even yours, reply live and answer chat messages. The more people chatting, the more fun it gets. And yeah, super chats definitely get priority. So drop your comment right after watching the video and I'll see you this weekend for the full recap and live Q&A. Link is in the pinned comment and description. Okay, let's look at SpaceFactory's technology, plans and roadmap for Lunar Roads and infrastructure. Lunar Roads. SpaceFactory states on their website they want to boldly build where no clear path exists. Using a combination of rapid prototyping and agile development, they're working on the first lunar asphalt road. The technique combines lunar soil with a biopolymer mix. After mixing and heating, the material is laid onto the ground, creating a strong road surface. The company is targeting the late 2020s to test this process on the Moon. This is why the higher cadence of Artemis missions is so exciting. It should accelerate lunar startups and get infrastructure on the Moon sooner than previously planned. Why lunar roads? Without roads, it's extremely slow to move around the lunar surface, resulting in reduced exploration, surveying, and science that can be achieved during a lunar day. With lunar spacesuits rated for at most 8 hours, and realistically less for safety margins, astronauts cannot travel far without roads. In addition, heavy or bulky equipment cannot be transported safely since even small craters, divots or slopes could cause tipping, or possibly cause payloads to become stuck or embedded into the lunar soil. Wherever there is human activity on Earth, roads are built. The same will be true on the Moon and Mars. Another major issue is dust. Rovers traveling on a rough lunar surface will kick up dust that will infiltrate equipment, scientific instruments and radiators, potentially causing overheating or short circuits. Roads practically eliminate this issue. SpaceFactory's plan for Lunar Roads. With NASA funding, SpaceFactory, in partnership with Michigan Technological University, demonstrated the construction of a durable lunar surface in vacuum conditions. The company has developed robots that can perform construction tasks in lunar conditions, laying and heating the lunar asphalt into a dense material that can withstand the continued mechanical stress of lunar vehicle traffic. The team tested the road by simulating a lunar rover wheel moving over the road 900 times. No dust accumulation was observed on the wheel. The company developed geogrids that increased the strength of the lunar soil-derived roads by 165 times. These geogrids, which make up only 1 to 2% by mass, are specialized materials that increase the strength of the lunar asphalt material. SpaceFactory estimates that by using local lunar resources, the amount of material needing to be shipped from Earth is reduced by 80%. Future work will push the technology to higher readiness levels to prepare for a lunar surface demonstration later in the decade. Okay, let's move on to another moon project by SpaceFactory. LINA, Lunar Infrastructure for NASA Artemis. SpaceFactory isn't interested in only building roads on the moon. They also plan to build habitats. Their approach is novel, however. It involves 3D printing layers not on the ground, but at a 60-degree angle. First, berms of lunar soil are prepared in advance, acting as an inclined print bed. These berms aid in anchoring the first layers. To prevent warping, metal tiebacks are inserted into the berm. As the roof begins to take shape, an excavator will follow behind the 3D print head to cover the structure with protective lunar soil. The lunar structure can be extended to a cluster of units to create a lunar outpost. The orientation of the structure provides shading, with the regolith providing protection from cosmic radiation and the occasional lethal solar flare. The 3D printer operates at temperatures ranging from -170 to +70 degrees Celsius. The first prototype, built by SpaceFactory, is undergoing testing at Kennedy Space Center in a lunar environment chamber that mimics the conditions at the lunar South Pole. The LINA structures are designed to have a life expectancy of at least 50 years. The habitat is safe from dust intrusion, moonquakes, and radiation. LINA is made from a combination of Earth-sourced polymer binder and native lunar soil, mixed together and heated to form a strong, durable construction material. The habitat is designed with a parabolic cross-section so that the loads are always in compression. Okay, that's the plan, but what about the challenges? Let's list a few of the challenges and problems SpaceFactory will face when building infrastructure on the moon. Lunar dust. The number one issue when operating on the moon is the lunar dust. It's everywhere, it's sharp and electrostatically charged. That's why lunar roads are key. Flat, compacted roads will stop or greatly reduce the amount of dust kicked up from rovers or other equipment moving around. This goes for lunar landing pads as well, which are essential to build early on in the construction of a lunar base. Reducing the mass of equipment. Earth-based construction and excavation equipment is heavy. That's going to be a big problem for the moon, where 1 kilo of mass costs $1 million to deliver to the lunar surface. Even with Starship, the cost will likely be $100,000 per kilo or more. That is why reducing mass and ideally using local lunar resources is so important. Okay, let's look at the competition. Competitors. SpaceFactory faces competition for lunar infrastructure business. As mentioned already, Icon has the same idea and has already constructed large test habitats for NASA. They plan to develop 3D printing machines for construction of lunar landing pads, roads, and habitats. Redwire are developing MASON, a set of tools for grading, compacting, leveling, and sintering lunar regolith to build roads on the moon and Mars. Ethos Space Resources and Astroport both plan to excavate and heat regolith, first to extract useful resources such as oxygen, but also to use the regolith for construction of roads and landing pads. Many other space companies, such as Blue Origin and SpaceX, have extensive plans for lunar construction, base building, regolith processing, and more. With NASA's increased pace and possibly 2 landings on the moon in 2028, it's an exciting time for lunar base construction and lunar startups. Final thoughts. SpaceFactory continues to develop and refine their technology, ready for a mission to the moon later in the decade. What do you think of SpaceFactory's approach to lunar roads and habitat construction? Is 3D printing of materials from lunar regolith the right approach? Do you think they will demonstrate lunar road construction this decade? Leave your thoughts and opinions in the comments section below. Thanks for watching. If you enjoyed this space video, consider buying me a coffee to help fund more episodes like this. The link is in the description. Watch the weekly live stream to see the images, clips, and slides from this week's videos. It's a live Q&A on this week's space topics where I read out loud some of the best comments. The more people join, the more fun the live stream is. Be sure to like and subscribe so you will see our upcoming videos. We make videos every week covering the space industry with an emphasis on the smaller space startups that aren't covered so well on other channels. See you soon.